From space, Earth shimmers like a blue marble, a breathtaking oasis in the vast expanse of space. But have you ever wondered what lies beneath that surface, what secrets are hidden deep within the heart of our world? This is a journey that takes us on an adventure to the center of the Earth. We'll travel through layers of rock and metal, each with its own story to tell, its own role to play in the grand symphony of our planet. Our journey begins with the outermost layer, the Earth's crust, a thin, fragile skin compared to the immense layers below. From there, we'll delve deeper, encountering the mantle, a region of churning rock that drives the very continents we live on. Further still, we'll encounter the Earth's core, a place of liquid metal and intense heat, responsible for our planet's protective magnetic field. So buckle up and prepare to be amazed as we embark on this incredible journey to the center of the Earth. Imagine the Earth as a giant apple. The skin of that apple, the part we see and touch, that's like the Earth's crust. It seems vast and unending, stretching out beneath our feet. But in reality, it's incredibly thin compared to the rest of the Earth. The crust is made up of rocks, minerals, and soil, all the things that make up our world. It's the ground we walk on, the mountains we climb, the ocean floor beneath the waves. But even within this thin layer, there are two distinct types of crust, continental crust and oceanic crust. Continental crust forms the continents, the large land masses we live on. It's thicker than oceanic crust, averaging around 30 to 50 kilometers thick. Oceanic crust, on the other hand, lies beneath the oceans. It's thinner, averaging around 5 to 10 kilometers thick, and it's made up of denser rocks like basalt. This type of crust forms the floor of the ocean, a hidden world of underwater mountains, vast plains, and deep trenches. So the next time you step outside, take a moment to appreciate the ground beneath your feet. It may seem solid and unchanging, but it's just a thin, fragile skin floating on top of a much larger and more dynamic planet. Beneath the Earth's crust lies a region of immense power and mystery, a place where rock flows like a viscous liquid, where unimaginable heat and pressure reign supreme. This is the mantle, a layer of solid rock that makes up a staggering 84% of the Earth's total volume. The mantle is about 2,900 kilometers thick and is mostly made up of a type of rock called peridotite. Unlike the solid rock of the crust, the mantle behaves more like a very viscous fluid over long periods. This slow, churning movement is driven by heat from the Earth's core, like a giant convection current. This constant motion is what drives plate tectonics, the movement of the Earth's continents over millions of years. The mantle's influence on our planet is profound, responsible for the formation of mountains, volcanoes, and earthquakes. So, while we may never see the mantle directly, its influence is all around us, shaping the very landscape we live on. Our journey to the center of the Earth now takes us to a truly alien environment. A place where intense heat melts even the toughest of rocks, where metal flows like water, and where the Earth's magnetic field is born. This is the outer core, a liquid layer of iron and nickel that swirls and churns some 2,890 kilometers beneath our feet. The outer core is about 2,200 kilometers thick and reaches temperatures between 4,500 and 5,500 degrees Celsius. Under these extreme conditions, iron and nickel exist in a liquid state, constantly flowing and swirling. This liquid metal is in constant motion, driven by the Earth's rotation and the heat from the inner core. This motion creates electric currents, which in turn generate a magnetic field that surrounds our planet, acting as a shield, protecting us from harmful radiation from the sun and solar winds. Without it, our atmosphere would be stripped away by solar wind, and the surface of our planet would be bombarded by harmful radiation. So the next time you see a compass needle pointing north, remember the incredible dance of liquid metal deep within our planet, a dance that generates the magnetic field that protects us all. Our journey culminates at the very heart of our planet, a place of unimaginable pressure and heat, a place where even the concept of solid takes on a whole new meaning. This is the inner core, a solid sphere of iron and nickel about 1,220 kilometers in radius, a testament to the immense forces at work within our world. The inner core experiences pressures over 3.6 million times greater than at the Earth's surface and temperatures soaring to around 5,200 degrees Celsius. Under these extreme conditions, iron, which would normally be liquid at such temperatures, is forced into a solid state, its atoms squeezed so tightly together that they can no longer flow freely. Despite its solid state, the inner core is far from static. It spins at a slightly faster rate than the rest of the planet, completing a rotation about once every 1,000 years. The inner core is a fascinating paradox, a place where extreme heat and pressure combine to create a solid sphere of iron that spins at its own pace, influencing the magnetic field that protects us all. As we've journeyed from the Earth's crust to its inner core, we've uncovered a complex and dynamic system, a planet that is far from static. The Earth's layers are not simply inert shells, they interact and influence each other in profound ways. The mantle's slow convection, driven by the heat of the core, shapes the very continents we live on. The outer core's swirling liquid metal generates the magnetic field that protects us from harmful radiation. The Earth's layers are a testament to the incredible power of nature, a reminder that our planet is far more than just a solid ball of rock. While we've learned a great deal about the Earth's interior, many mysteries remain. The extreme conditions deep within our planet make direct exploration impossible, so scientists must rely on indirect methods such as studying seismic waves from earthquakes to piece together the puzzle of our planet's inner workings. How exactly does the inner core rotate? And what role does this play in generating the Earth's magnetic field? What is the precise composition of the mantle? And how does its slow convection drive plate tectonics? These are just a few of the questions that continue to fascinate scientists. As we develop new technologies and refine our understanding of our planet, we can look forward to uncovering even more of the secrets hidden deep within the heart of our world.